Well, this is a weird set of things to have. It might look weird to you, but how about I show you what my custom CoPilot PC sees? This isn't CoPilot like Microsoft's CoPilot though. I can't recall what it was, but there was just something I didn't like about the way Microsoft marketed that thing. That's why I built the CoPilot, literally a Raspberry Pi AI PC. Microsoft says you need at least 40 TOPS of neural compute for CoPilot. While this version only has 13, later in this video I'm going to go for 47 TOPS. That's faster than either Apple's M4 or the Snapdragon X. How am I doing it? Well, for starters, I'm using this. The $70 Raspberry Pi AI kit includes an M.2 hat and a 13 TOPS Halo NPU. It's like a little machine learning jetpack strapped to the back of a Pi. Earlier this year, I used a Coral TPU with my Frigate server. It's detecting cars, people, and even sometimes what it thinks are birds. The Coral is $60 for 2 TOPS, and it gets around 2 TOPS per watt efficiency. The Halo 8L here is a modern souped up version. It runs at 13 TOPS and 8 TOPS per watt. The AI kit will sell for $70, and right away, I have to throw up a huge disclaimer. This is called the AI kit. The AI hype train is full steam ahead with Apple, Microsoft, Google, NVIDIA, Meta, well, pretty much everyone is all in on AI this year, and I guess Raspberry Pi is too now. But AI is a lot of things, and really, in my book, it's machine learning, or maybe you could call it neural computing, but AI generates buzz, so it is what it is. That doesn't mean this thing's useless, though. It's not like a Rabbit R1 or a Humane AI pin. This thing is geared towards actual use cases, like machine vision. And that's why I think all the hype is going to be around Pi cameras. Raspberry Pi even pre-announced an AI camera at Embedded World this year. This video from Tam Hanna has a few close-ups. But this is more generic. This thing is a PCI Express device you plug into the Pi, and you could use it on other computers too. It accelerates generic machine learning tasks like object detection, pose estimation, or image segmentation, like how an iPhone does portrait mode. It can do some other things too, but cameras are probably the #1 practical application right now. Like even at the Sony factory where they build Pis, they use AI-powered cameras for some of their inspection and QA. I don't normally cover AI stuff on this channel because the hype is reaching cryptocurrency levels of insanity. That, and I usually like technology that solves problems. A lot of AI stuff I see is a solution in search of a problem. But Raspberry Pi is focusing right now on real-time video. Like Frigate can just save clips where people are detected instead of recording 24/7. Or traffic planners can count cars on a highway just with one camera. Factories can monitor production lines and farmers can monitor for spoilage. These are actual real-world problems being solved today. There are even individuals using machine vision in their wacky experiments, like this guy finding tardigrades with an automated microscope. There's also robotics, of course, and safety monitoring. Tons of things can be better with a little low-power AI coprocessor and a Pi. But why didn't Raspberry Pi just bake in an NPU into their main chip, like Rockchip did with the RK3588? Well, take that one up with Broadcom. Raspberry Pi doesn't build their own chips, at least not the main one. But it is interesting watching different approaches. On one side you have Apple, Qualcomm, and Rockchip building in custom NPUs into their main chip. On the other you have edge devices like the Raspberry Pi that you can add on AI. And then there's ARM, who's pushing for AI extensions right on the CPU. I mean, every approach has its benefits. Like with enough cores, a CPU can definitely muscle through it, like when I was running LLMs on my 128 core Ampere Ultra Max. But the Raspberry Pi only has 4 cores and a power budget of a few watts, so Halo it is. But then, why not use a GPU? NVIDIA's on top of the world right now with all their fancy AI hardware. Are GPUs better than NPUs like the Halo? Well, yes and no. GPUs are great for training and running models, but they typically have higher power requirements, and working with them can be a little challenge, especially for devices you might want to run at a few watts on the edge. I don't think farmers want to have 4090s gobbling up 600 watts of power crunching plant data on their tractor. The AI kit does have constraints though. It doesn't offer a ton of RAM, so the models you can run on it are a little limited. And forget training. I've tried training a model on the Pi 5, and it's not impossible, but it takes like days versus minutes or hours on a modern GPU. Anyway, enough about AI. Let me show you a few things this can do. First, for reference, I ran YOLO v5, an object identification model, on the Pi 5's CPU without the AI kit. You can see it does an okay job picking things up, but it's really slow, like 2 or 3 frames per second. The CPU is also going crazy the whole time, and the Pi is burning about 8 watts of power. Now compare that same model running on the Halo. It's night and day. It's showing objects as I move them around in real time. Not only that, when I open up HTOP and look at the CPU usage, it's practically nothing, just the work rendering frames out to the screen. The whole system's only burning 7 watts of power too. That means if you use one of these accelerators, it's faster, it uses less power, and it leaves your CPU to do other stuff, like run useful software that reacts to the objects that you detect. Or you can do pose estimation, basically in real time, so you could build gesture-based apps. Pose estimation is also useful for things like predicting behavior. Instead of just knowing there's a person in front of a car, the car can see where that person's looking and moving. Then there's applications like zoom and portrait mode on the iPhone. Using image segmentation, you can either cut out an object, exclude it from a picture, or even do unique lighting effects in real time. Having a dedicated AI coprocessor means the Pi can even monitor feeds with dozens or hundreds of cars or people. These models aren't perfect, but you can tune them with your own data to get even better. And to get you started, Halo has a model zoo. It has pre-built models for things like upscaling and face recognition. And Raspberry Pi is building out their own documentation too. Having first-party support is going to make it easier to integrate into other projects. Like, I don't see any official Frigate integration yet, but I'm sure that's going to come soon. And I wonder how long it'll be before projects like StereoPi use it for better robot vision. But there are some things this can't do, or at least it's not going to be great at. Like, if you want to build a little image generator, it's not the best thing for that. You might get something like Onyx Stream to run on, maybe, but it just doesn't have the RAM for that. And large language models like ChatGPT typically need beefier machines. The NPUs still could be useful, like Softgo supports some LLMs on their TPU, so it'd be interesting if you could run something smaller like Ollama. But I've kept you waiting long enough. We need more than 13 TOPS of neural compute to beat Microsoft, so I'm going to pull out my little box of PCI Express goodies and we'll see how far this thing goes. Let's clear away a few things first. The main star of the show is going to be Pineboard's Hatbrick Commander. PCI Express board that adapts one port into two. Also this guy, which is another Halo. This is the 8L, which has 23 TOPS or something like that. I also have a few other specialty boards here. These are my collection of corals. And I have a few. This is a mini PCI. This is a ANE key. And then this is my special dual Coral NPU with two of them, so there's I think 4 or 8 TOPS on there. So we're going to try to get as many TOPS as we can connected to this Pi. It might be hard to use them all at once in software, but you could have multiple containers running different models on different NPUs. So in aggregate, we'll get the number, but we're not going to have the exact same setup as a CoPilot PC or Apple's M4 or something like that. And I actually have 2 of these commanders so that we can hopefully get 3 external PCI Express devices connected. Okay, now we have 2 connections. Now we have enough connections for 3 boards. And this board has its own PCI Express switch on it, so I can put in hopefully one of these Halos and Coral TPU here. So we'll see if we can get that working. And this is another special board. This one has its own PCI Express switch, and it allows me to put this dual TPU on here, and hopefully both of these TPUs will be seen by the Pi. Oh boy, this is a little precarious. This is a terrible idea. Don't try this at home. And I need the camera. Well done. But nothing's touching each other right now. I'm going to try to plug this in and see what we get. There's power on here. Power on there. No power on this one. I think the pinout is different on the Pi's M2 hat. Let's see what we see. Coral edge, coral edge, coral edge. So 3 corals. That's 1, 2, 3. And the Halo 8 there, but we don't see the 8L. I'm going to have to put that on a different chip. So hold a second. Okay, we're bringing in another Pineboard's product, the Hat Drive Top. This is a wildly unsupported configuration. I don't think Raspberry Pi would recommend that you try this at all. And now I have 1, 2, 3, 4, 5 different Pineberry boards connected to this thing. We're going to see if this will boot and recognize everything. It's always good when there's no magic smoke. I see power on everything. This is good, and there's power on the Halo board. Okay, so far no sparks, no explosions. LSPCI, and it actually works. Let's see. We have a bunch of switches. We have the dual edge TPU, so that's 2 TPUs, Halo 8, Halo 8L, another Coral TPU. That's it. Now let's see if we can still run one of these models. I have this camera going over here. Ooh, okay, so with all this, it doesn't look like it can boot up the Halo. Probably a power requirement issue. It's saying Halo RT not ready. And if I go back over here, demessage. What I'm guessing is happening is I have so many things plugged in right now. This, the Pi's PCI Express port is meant to supply up to 5 watts. One of these Halos can use 2 to 4 watts or something like that. So if you have 2 Halos, a dual edge TPU, a single Coral TPU, that's a lot of watts that it's trying to pull down. So when it tries to initialize, I think that what's happening is it just runs out of power and it has like a brownout. So there are 47 TOPS of neural compute plugged in and recognized. It's just not quite usable. And I think that I might be able to get it usable if I use Alphatel's 12-slot board with some adapters. That's an experiment for another day, though. You can get external power. I think what's happening is there's just too much power draw, or there could also be bugs with having 2 or 3 PCI Express switches in line in front of one of these devices. It didn't work out, but even if it did, it's kind of an abomination. It's probably better just to buy a beefier NPU if you really need that power. Like, Halo makes a line of bigger cards with 52 to 208 TOPS of performance. Those start at $250 though, so if you don't need that performance, save some money and get the AI kit. But we're still in early days. Will the AI kit be useful? Definitely for some people. It's great having a solid alternate to the Coral. It'll be interesting to see how Halo evolves with this new exposure. I know they used to require registration just to read documentation. I think that's changing, and hopefully they can be a lot more open with their AI products. And beyond an AI chip like this, there are hints we might see things evolve even further. I have a useful sensor here that detects if someone's face is in view and makes it easier to build microcontrollers with presence detection with no need for a Pi at all. Then companies like ArduCam have the Pi Insight camera. It blends up AI and a camera module and even adds built-in hardware encoding for H.264 and H.265, something the Pi 5 doesn't have built in. But the AI kit, I like it, though it is a little niche. Like, probably 90% of us don't really need it, but there are a lot of people who are gonna love it, especially for machine vision and robotics. It's great to have another option now besides the Coral. Until next time, I'm Jeff Geerling.